Such a fantastic group. So yes, thank you again to everyone that joined that panel. Really, really exciting one next. Technology is a wonderful thing when it works. You know, like when the slides don't load, for example. My fault. So to talk a little bit more about technology, we have two excellent speakers. So we have Glenn Tookey from Sight and Sound Technologies, and we have Robert Quinn from Imperial College London. Both are working on some absolutely really exciting, cutting-edge future technologies. So I think, Glenn, we have you coming up first to talk about all things, maybe including, I don't know, robotic guide dogs, perhaps. Over to Glenn.
Well, good morning, everybody, and that's been a very, very interesting session so far. Deep, very important, and I feel somewhat a bit of a fraud turning up here to chatter about technology, but that, I know, is really very important to you guys as well. But it's a sort of turn from very serious to perhaps a little bit lighter, and I'm going to talk to you. We've only got about half an hour before lunch, so I'll chatter to you probably for about 10 or 15 minutes, and then my colleague Robert Quinn will come along with what I think is the best example of what I'm just about to talk about, because technology is something that we know has to work. And well, I think the first thing I'd say is the future is bright. It might not be orange, but the future is bright in terms of technology. For the first time in the 15 years I've been in the industry, I now see multi-million pound investments in new technology for people with sight loss. And that's fantastic, because I arrived in 2008. Many of the products and technologies that you rely on have been around for a long time. And we get to 2013, 14, 15, 16, and I felt it hadn't changed that much. Maybe Orcam came along and started to change it. But since Orcam has arrived, and many of you have seen that as a very smart piece of text-to-speech technology, things have started to move on at a pace. But my experience is that a lot of the new technologies that arrived in the last 2 or 3 years don't quite work well enough for people all of the time. They work for some people some of the time, and they cost a lot of money, 3,000, 5,000, 7,000 upwards pounds. And that, as a provider of technology, a supporter of technology, makes me feel bad. And so I set out to scour the world to try and find people who are investing in technology and doing what I hope to be a good job, and maybe even helping them in those last stages of getting technology to the market that actually works and is worth the money you pay for it. So I'm going to just romp through some of the things I've seen in the last couple of years, which maybe give us all a little bit of hope in the future that technology will support our daily lives better. But some of the words I'll use, like artificial intelligence, apps, web-based, tells us that if you're not perhaps a smartphone user, if you're not up to where technology is at today, then some of the technology coming along may still be beyond your grasp. But I'll tell you about what I'm seeing, and obviously take questions at the end, and my colleague Rob will come along and tell you a little bit about his product, which I think is a great example of what we're looking at. So yes, Matt, robotic guide dogs. I have seen the future, and it may well be a robotic guide dog. The one I've seen, well, actually, they all come into an area which I think is the holy grail, and it's navigation. If we can get someone with low vision from A, not just to B, but to the seat they need to sit in, C, then I think we've cracked it. And I think the good news is that's where most of the investment is going into. I'll talk about a couple of other areas in a second, but the big one I see the money going into is navigation. And the trick is getting it down to that last 6 inches, because a meter's not good enough, is it? If you're going from A to B and you're a metre out, you may well be in the middle of the road, and that could be catastrophic. So getting navigation to work beyond what Google Maps will tell you, or show you, is I think the key. So I found Pepper the robot, 1 metre 20 high, robotic, well, robot, not a guide dog, just a robot. Pepper is clever. Pepper has mapped the internal area of about 100 square meters, and when you turn up to see him, he uses his cameras and artificial intelligence. You tell him where you want to go in that space, hold his hand, and he'll take you there. Okay? He'll take you there. Now, he's no good outside because his little legs and his little wheels fall down the potholes that the UK is full of, sadly. But inside the building, Pepper is very good. A to B, trundles along, takes you there. But Pepper can't go up and down the stairs. Go in the lift, though. But I found the mini cheetah, who actually is really a robotic guide dog because it actually looks like a guide dog. It's nice and silver, and it's got legs, and he or she can go up the stairs. And it's got a little leash. So you hold the little leash, you tell where you want to go, and it actually will walk you from A to B inside that space and up the stairs. And you think these things, will they come to fruition? Are they viable? Well, I'm not sure they're the sort of thing that you might buy for yourself to work around, but I think they're the sort of technology that you'll find when you go into a public space, maybe like here, maybe a museum, maybe even a restaurant, that could actually have mapped that area and get you from A to B. I found others. I found one in Singapore called the e-guide dog. That's quite a clever piece of technology. Does all the things I've just talked about, using AI and cameras, navigates you from A to B. Got a bit of obstacle detection in there as well. Quite clever, can see something coming towards you, map the trajectory, the speed, and decide whether it's going to hit you or not, okay, and then move you to the right space. Now that recognises traffic signals, red or green, so it won't let you cross the road until the traffic light is green. So that's happening in Singapore now. That one is outside, it's got bigger wheels and can trundle along. So that's out there. So it might be a little bit light-hearted, but actually it's real, it works, and the technology is getting you from A to B, all using AI. A little bit closer to home, and actually here in the market now are the smart canes. WeWalk you may have come across, very decent navigational tool, but I know that is moving on in technology, and the next iteration of that will have computer vision and will be, I think, the next step up. You may have come across Rango in France, which actually has not just a smart cane, it has ultrasonic detection, also can map obstacles coming towards you and will route you around them. I had my first experience of being someone with no sight. I was blindfolded in the street in France, given a Rango cane, given 10 minutes of tuition, and then told to walk a mile to the station. And I'm still here. So I made it. That was really clever, because as I reached every intersection, it told me the intersection, it told me the roads, but I still had to work out how to cross that road. But it got me there from A to B. So on the market today is product that you can take. Heard of Biped? Biped is sort of smart cane plus, in as much as you need sometimes your hands free, particularly if you've got a dog. So Biped actually sits over your shoulders. It's worn a little bit more like a vest. Now that again has obstacle detection, has GPS, can get you from A to B, and that's a Swiss-based product which gives you two hands and will allow you to navigate that way. That's quite a good one. That's got height detection and depth detection. So if you're approaching a set of stairs, it won't let you go up, it won't let you go down, but it'll tell you with a change in the cadence of the tone whether you're approaching an upward incline or a downward incline. So again, this technology is getting very clever. It's using artificial intelligence, it's using camera vision, it's computing it all in real time, and it's getting you sort of pretty close to getting from A to B. You can move back and look at some of the older technologies. There's beacon technologies around and QR code technologies around, which I think are pretty old technologies actually, and will soon be surpassed. But I think the key here is, and I think it's really important, that whilst I've talked about perhaps robotic guide dogs, robots, things that can take you from A to B, when you go into a location, perhaps you need to be able to just get around that location without having had any technology of your own. And that's where the beacon and QR codes are perhaps a little bit old hat, but maybe the area's been mapped. What I'm seeing now is community mapping. I'm seeing organisations, Waymap, Good Maps is probably the forefront of this, that start to map these locations, share the map, a very, very accurate map, into the cloud, so the next person who arrives at the door can actually pick up that map onto a smart device and navigate from A to the point in the building they want to. Now that's costly, that's time consuming, but what I think I can see happening here is an organisation or two will become the mapping experts. They will map and they will share the maps with others building this technology. So you don't have sort of 300 mapping companies, you have one or two who are mapping for us all. The key here is community mapping. Up into the cloud, pull it down, and off you go. Again, you need smartphones, you need the latest technology to get hold of this, but it's out there, and this level of mapping will take you down to a metre or two, and sometimes even with good mapping down to a foot or two. Then I think you're getting to safe levels of navigation. I've looked at obstacle detection, lots of belts, lots of straps. They're very good until you put a coat on, then it can't see where it's got to go. Some of them are covered by clothes, so that doesn't work very well. One that I really enjoyed was one that strapped to my shoe, a little sensor on the front of my shoe, and that works quite well. Haptic feedback though, buzz for left, buzz for right. I moved a little bit faster, got a little bit overconfident. The sensor threw off the end of my shoe, flew across the room. I was stranded and a little bit embarrassed. I had to hunt around for someone to find my sensor and put it back onto my shoe. That's in Austria. I don't think that one's going to make the market anyway soon. But you can see there's quite a lot of different levels of investment going into navigation. Some will work well, some will not work quite so well. But I do think, from my experience, those that just rely on haptic feedback, buzzing, vibration, and sounds are probably not going to be granular enough to get you safely from A to B. You're going to need AI, you're going to need some form of computer vision. So navigation, I think, is the holy grail, and that's where a lot of the money's going in. Of course, ChatGPT-4 is driving quite a lot of this. I think this is where you really are going to get some bonus out of the very latest technology for low vision. So much of what you do relies upon you scanning something, reading it back, and having to listen to a serial audio chain before you get to the part that you want to. A restaurant menu, if you want a pizza, you have to wait until that comes up in the long list of the scan and read that you've taken. ChatGPT-4 now, and this is already wrapped into a couple of devices that we have at Sight and Sound Technology. The Envision glasses is a great example where you can now question the device and say, take me to the pizzas, or how much is the margarita pizza? And now that technology will route you very quickly to that place in the image that it's taken and only give you that information that you need. So that, I think, starts to make this type of technology really, really usable. So you don't have to sit for minutes waiting to hear the right space in the audio that you may well have missed. So that, I think, is very, very clever. Seen quite a lot of work going into sighted assistance. Be My Eyes, a very good example. Aria also. But I do wonder if people are that keen on talking to somebody they don't know, and that person could be somewhere else in a different location worldwide. So some of the technology I've seen now wrapping into devices, chiefly for the blind rather than low vision, is the ability to make video calling, so that you can call somebody that you want to call, who can take over the camera, see what you can see, and guide you through your ear to the place you want to go. And I think a little bit of is where we're certainly going to start. A little bit of AI to be able to filter down the information, but sometimes a little bit of help from someone you know to get you to the right place. So that's the key things I see in the consumer world. The other place I've been quite recently is in the world of diagnostic technology. And this again, I think, may be another game changer. So often the technology costs 20, 40, 50,000 pounds for a trained clinical or professional to be able to take the information, interpret it, and give you the answers back. But I've looked at OcuWell, POV scope, IO Perfect, even the little visual fixation system. And what are these? These are apps mounted on a phone, small mobile handheld device, operated by someone with a lot less training required, a lot less knowledge of the eye conditions, picking up the information, but that information is now routed in real time back to an expert centrally who will take that image from the back of your eye and will interpret that and get that information back to you. Now I see that diagnostic capability, information and cost and speed is coming right out into the community, even so you can probably take that app home and take images of your eye or your retina or wherever it may be seen and get that back to an expert. Now I think this is really going to be a game changer, and I see one or two of them coming to the market in the next 1 to 2 years, which I think starts to make your lives so much easier than having to trawl yourself around a hospital somewhere and wait in a queue, because I think it can come to you. So that also is, I think, where we're going to see some big changes. Now I'm going to cut to my friend Rob, because he has got the very best of the sort of technology that I've been looking at for the last 2 or 3 years, so much so that I'm actually now doing some work with him. But his Make Sense technology that he's going to talk to you about, I think, is where we're going to go with the navigation world. So I'll hand over to Rob in a second, but say thank you for coming with me on my little romp round the world. But I just say again, there is a lot of technology out there. There's a lot of investment going in. I think if I'm standing here in 3 years' time, you're going to have immensely more solutions at I think at a more affordable price that actually work for you. So I think we've got a step change now than we've had in the last 5 or 10 years. Thanks very much, and I'll pass over to Rob.
Hello everybody, I'm Robert Quinn. I'm a visiting researcher from Imperial College London in the area of sensory substitution, which is an academic research topic. I'm also the CEO of a spin-out from Imperial College called Make Sense Technology Limited, and we're developing sensory substitution technology that we're trying to commercialise at present. Yeah, of course. So what I'm going to do first is going to try and summarise the challenges that are needing to be overcome in order to make some of the technology Glenn was talking about useful for people that have sight loss. So computer vision, for example, it's with these robotic guide dogs, these things like the Pepper robot, with computer vision, it's possible for a robot to navigate this room autonomously with no prior knowledge of the room, using something called SLAM, simultaneous localization and mapping. It's what Tesla will use as it's driving through an environment it doesn't know about. But the problem with SLAM and pretty much any computer vision is that it requires a ridiculous amount of computational processing. So we've calculated that in order for a product to be useful enough and effective enough for it to navigate through an environment without any prior knowledge of it, it would need to have a processing power of about 20 tops. And what that means is, so you've got, that means tera operations per second. So you've got giga, that's a million. So you've got mega, a million. You've got giga, a billion. Tera is a trillion operations per second. 20 trillion operations per second. But luckily, the graphics processing units that are available these days are getting very, very sophisticated very quickly. So you might have heard of Moore's law. So every 2 years, the transistor density on CPUs doubles, basically, or approximately doubles every 2 years. But there's a different law for graphics processing. It triples every 2 years. So this exponential growth with a third more each time it means that in 10 years' time, there's going to be a ridiculous amount of processing power, even just in our smartphones. So the latest iPhone 14 has the processing capacity that's needed to do SLAM for navigation. So the problem then is if you can map a room, you could find your way through it using kind of robotic automation systems, is how do you deliver the information that's needed with enough granularity to give you the guidance to get you to within, so Glenn was saying, 6 inches of where you want to go. The bottleneck isn't in the SLAM. It's actually in the information delivery mechanisms that are available at the minute. So, I mean, for example, you've got the latest iPhone 14. It's mapped this room, got some incredible technology, it knows exactly what's going on, knows there's a gap there, knows there's a door there, it can take you through it. But using just vibration or audio it's not effective. You simply cannot communicate enough information to somebody to make that very granular journey. It's very good at providing general guidance, like turn left soon. But if you want it to guide you fluidly through a crowd, for example, it's just not going to work. So this is where this kind of sensory substitution stuff comes in. So sensory substitution means passing information through a sensory modality that's not designed to receive it. So, for example, you could pass audio information through the visual sense, or you could pass visual information through the auditory sense, for example. But when it comes to substituting for sight, our sight has a bandwidth of about 10 times more than all of the other sensory modalities combined. So trying to pass visual information through even all 4 of the other senses at once is not going to work. And people have tried it. It's been an academic research topic since the 1960s. Millions, probably hundreds of millions, have gone into trying various things out. But what we've developed, and why we've started this company called Make Sense, is the world's first effective sensory substitution device for vision. So it can pass visual information through your sense of touch, but it does so in a very clever way that utilizes AI. So I'm going to take a guide dog, for example. So a guide dog is taking visual information in through its eyes, it's using its brain to process, where you are, where you want to go, what you want, and you can communicate with the dog, tell you what you want it to do. And then the dog doesn't pass all of its visual information to you. It passes a tiny, tiny fraction of that to you consistently through your sense of touch. So it will give you momentary stimuli constantly to take you through the room. You don't need to know everything about the room in order to get to where you want to go. You only need to know where you need to go at any particular moment in time. So if you actually look into it, there's more than 5 senses. One of these senses is called proprioception. So proprioception, with that sense, we know where our hands are without having to look at them. So you can still touch your forefinger on your nose, regardless of the kind of level of sight loss you have. And so leveraging the proprioceptive sense, we can also make another observation, and that's that humans have an ability to infer a location by pointing with their hands. So even congenitally blind children will point with their hands in experimental setups towards auditory targets, for example. So I think the key to delivering this information is to actually prompt someone to point in the direction they need to go. So if you can imagine you've got like a handheld, it's called a haptic interface, like so passes information through the sense of touch, device that's constantly getting you to move your hand around as you move through a space, then it could take you anywhere. It could be subject to the software being sophisticated enough, as good as a guide dog for navigation, or as good as a sighted human guide, particularly if you can interact with it through these large language models like ChatGPT that Glenn's just talked about. We have developed this technology. We've proven that it works through some early trials in collaboration with Blind Veterans UK, Imperial College. And in this summer, we'll be doing some more in-depth investigations. We've got some research funding So if anyone here is interested in taking part in these trials, they'll take place in London. We'll be doing some navigation experiments with our technology. And so, yeah, just to recap, I think the technical challenges that are related to enacting the visions that Glenn has talked about are not so much in the actual software side of things. I think because there's billions and billions of dollars going into autonomous technologies. So everyone, hundreds of billions are spent on researching driverless car technologies. It's precisely the same thing. We can grab that and kind of repurpose it for our needs. And it's the interface. A Boston Dynamics walking guide dog, yeah, it sounds cool, but it's not practical. They cost £250,000, and they probably run out of battery in about an hour. In fact, they don't even have electric motors, and they're hydraulically powered, so they've got pistons though, jogging along because you can't get the power you need out that size otherwise. So yeah, thank you for having me here. Mark Baxter, who's a friend of mine, invited me here. I've been working with him for a couple of years. In fact, he's now employed by us as well as Retina UK as our implementation lead. And if you want to chat to him about his experience of using the device, then I'd encourage you to do that as well. Thank you.
I've understood all of that.
Hang fire 2 seconds, just make sure we've got a microphone to you, just so people at home can hear. So, yeah, first point was, I just want to say, so Rob, you said about Mark joining you. How did Mark come to start working with you?
So I finished my PhD at Imperial College 2 years ago, and when I finished, I was fascinated by this whole subject of sensory substitution. So I applied for a research grant. I want to try and make a sensory substitution device for people that have sight loss. And in the process, because I didn't have a background in this kind of knowledge of this kind of area of visual or vision impairment, I reached out to some charities and I said, look, I'm a researcher from Imperial College. I'm trying to make something that's going to help people. Could I interview some volunteers? And so I interviewed Mark's brother first, just to try and understand, what should I be trying to do with this? I mean, what's the most useful things we can do? And then about a week later, Retina UK emailed me and said, someone wants to speak to the engineer from Imperial College because he's got an invention that he wants to talk to you about. He was like, will you speak to him? I was like, yes, absolutely, I'll speak to him. I mean, I might even help him make his invention. And so Mark has a background in kind of inventing things, and so we immediately, as soon as we started talking on the phone, we were talking for hours, and he wanted to make some talking kind of digital calipers and tools. I was like, that sounds like a great idea, I'll help you make that. And in the process, we've just become friends, and he's been providing invaluable kind of support and guidance and early testing for our technology. So that's how I got to know Mark, and that was about 2 years ago.
That's fantastic. It was great. We were able to make that connection between you and Mark. We've got a question on the left-hand side of my room.
Hi, my name's John. It was a point and a question, really. And one of the points is I have difficulty trying to find things in a kind of dim light. But whereas if I put my Samsung Galaxy phone on, the camera in that is actually much better than my sight. So I can remember phoning up Galaxy before and saying to them, could they not provide something similar to that? So I could find a coin on the floor with the Samsung Galaxy, looking at that. If I've used the camera on it, or the video. But also that proprioception thing you mentioned, I find that really interesting, but so complex. If you've got the people's vision, surely it's trying to convert that, all the processes of vision to, say, like touch, the soma senses or whatever. Would that not be decades off?
So maybe I didn't explain this very well. So we're not trying to pass all of the visual information through your sense of proprioception. We're just trying to pass the one useful piece of information, which is where precisely should I be going at this very moment in time. So like with a stimulus that changes, say, 100 times per second. So like if you imagine a guide dog leading a person through a room, it's doing so using the person's proprioceptor kind of understanding in their brain to know where it's trying to pull you. The dog isn't trying to describe the location to you, it's not trying to do anything like that, it's just simply trying to communicate that key piece of information at any point in time. And so I don't think I understood the first part about the Samsung Galaxy camera finding a coin on the floor, but the same kind of technology that could be used for navigation could also be used for finding objects using object detection inference AI. So you're seeing AI Microsoft app, for example, you can identify objects. But then there's it's a little bit of a limitation in that you can identify, I could take a photograph of this room right now, send it to Microsoft Azure Cloud, and it will tell me everything in this room, where it all is, bounding boxes around everything. But then trying to locate that object within the room with just the audio and vibration that phone provides is difficult. I'm not saying it's impossible, it's just not practical. And it's difficult to use. So I don't know if that answers your question.
Well, it's probably step in because there's danger we drop into sort of quite detailed information. I think what we're saying here, Rob's device, firstly, will point you in the right direction. So you're holding it, and it's going to point to where you need to go. One thing, whether you've got sight or not, that you do know, generally, is where your finger's pointing, up, down, left, right. So firstly, you get some information that way. Secondly, it's going to pick up information from the cloud, from recognising objects, recognising scenes. And thirdly, it'll pick up information because someone actually drops a breadcrumb trail to a point. So there's a number of pieces of information can come together, and without you having to have all that information, it knows, therefore, where you need to be, almost, I guess, to the inch, if need be. So nothing's actually necessarily trying to feed you all of the information that your eyes would give your brain. It's actually picking up from a number of different sources, just enough information to get you to where you need to be. So all you need to do is tell the device where you need to be, and if it knows, it will take you exactly to that point. And Rob has cracked this, and he was telling us in some detail why his technology is better than some of the other technologies that I've seen around the globe. I'm convinced of that, which is why I'm working with him in his project as well. So it's getting the right information and getting it to you rather than all of the information, which I think is the key point.
One last question at the back.
Okay, so I do have two questions, but I think the one that I'm most curious about is I wondered if either of you had any comments on the, because you were talking about Be My Eyes, and I was just wondering if either of you have heard about or have any comments about the new feature that is hopefully going to be coming out later on this year called Virtual Volunteer. Yeah, I was wondering if either of you had anything to say about that.
Yeah, I know about it. Do you?
Yeah, I'm not familiar with them.
So yeah, Virtual Volunteer, as far as I understand it, is essentially integrating ChatGTP so you can interact with what it's telling you. So for example, you could be standing in front of a vending machine, and computer vision could tell you, oh, you're standing in front of a vending machine. And then you can query ChatGTP and say, what's in the vending machine? Because it can understand your intention. You'd be like, well, probably mostly Lucozade. And they'd be like, okay, well, which number is the Lucozade? And it was like D7. Can you understand with that level of granularity what's going on? I think that's absolutely incredible. I think that's amazing. Like probably the biggest step change in assistive technology that has ever happened. Still, I don't know whether it's going to be that useful for navigation, just because, I mean, for example, like a audio guidance doesn't really go to that low granularity that's needed.
But I think this is the key point, actually, that I was referring to earlier, where instead of getting a serial amount of information, and a little bit like Be My Eyes, having someone who can actually see what you can see, or certainly with things like the Envision camera, where someone can take over the camera, then you can cut out a lot of information you don't need to get to the information you do need. And I think that's what that could achieve for you, is that very fast razor point of getting the info you need when you need it. I think it'll be positive. It's got to be good, isn't it? One last question. Then you get your lunch.
Hi Rob. Really excited by the work you're doing. I just wanted to ask, is your technology API based so that could be leveraged by all tech companies, or is it just going to be like a standalone device?
No, we want to make it, so we want to have our own proprietary kind of means of having it deliver information, but there's absolutely no chance whatsoever we're not going to leave it open for other people to develop with. So I mean, for example, Good Maps, I don't know if any of you guys have heard of this company. They've scanned a lot of the Asda superstores in the UK, lots of the train stations, and they can precisely locate you within the environment you're in. So like that technology is brilliant, and it would be something that we would work together with them through an API. In fact, I already know Neil Barnfather, the CEO of that company. He has severe vision impairment himself. He's very excited about working with us on this technology. In fact, I'm visiting him soon in Milton Keynes, where he's based. There's lots of other opportunity, for example, with Be My Eyes. So at the minute, it's audio assisted by volunteers or ChatGTP in the future. But imagine if it could be, imagine if someone could teleassist you by, through this kind of technology, you could provide a huge step change in how useful all of these things are. So absolutely working with everybody who is in the field. We're like very collaborative by nature. And yeah, so if there's other people here that have, are working on this technology, I'm all ears.
Thank you so much. Fantastic. Thank you to both Rob and Glenn. I know Glenn's certainly going to be here over lunchtime, so please do, as will Rob, there we go. So please do take the opportunity to go and speak to them in the exhibition space. So it is lunchtime, you'll be pleased to hear. It's certainly a lot cooler over in that room than it is in here. So go and grab your lunch, and we would very much like to have you back at 1:05, please.